Chapter 9 explains spatial joins, which is another powerful GIS tool. A spatial join is similar to an attribute join, except that instead of using a common join field to decide which rows in a table match, the locations of the spatial features are used. If we recall, attribute joins require a destination table, the table that receives the data, a source table, the data that's added, and a common join field, a field which links the two tables together. Spatial joins also join the attribute tables together, and the terms destination and source still apply. However, there is no common join field, but instead the join is made by the spatial relationship. Spatial joins may be performed on any two spatial data layers. Spatial joins always create a new permanent data layer rather than being temporary like attribute joins. You can join points to points, polygons to polygons, lines to points, and nearly any combination of the three types of data. The output layer will always have the same feature type as the destination layer. A distance spatial join appends the records based on which source feature is the closest to the destination feature. In this case, the airports is the source layer, while the cities is the destination layer. The inside join appends the records of all the source features to the destination features that fall inside it. The definition of cardinality is the correspondence or equivalence between sets, how sets relate to each other. For example, if one row in a table is related to three rows in another table, the cardinality is one to many. The rule of joins applies to spatial joins as well. With spatial joins, we must use a summarized join if we encounter a one-to-many relationship. The type of join will group many city records are summarized into a single record and join them to the airport destination table. Summarized joins are used to handle those one-to-many relationships. They determine the relationship, summarize the source features to match the destination features, then append the summarized records to the destination table. Spatial joins fall into three main categories according to the cardinality of the relationship between the join layers. In a one-to-one or many-to-one join, the rule of joining is followed, and a single record in the source layer can be assigned to a single record in the destination layer. This case may be termed a simple join. In other cases, a one-to-many relationship exists, and the source features cannot ambiguously assign to the destination table. In the case of ambiguous joins, the join operation offers two ways to decide how to match the fields. One choice is to summarize the points occurring in each polygon in some way. A summarized join is performed. The join groups all the records matching a record in the destination table and calculates statistics for the group, such as an average. The average is then assigned to the destination table record. Alternately, a distance join could be implemented in which the distance record is assigned out of the many matching records, and out of the many matching records, the record it was closest to. One-to-one and many-to-one relationships are unambiguous. Either an inside join or a distance join may be requested. This example shows an inside join. The user has requested to join schools to counties, a one-to-many join. Counties is the destination table, and each county can have more than one school. Based on the destination and source layer, the software determines the appropriate join type and gives the user two options. Option 1 is the summarized join. Each county feature will receive the summed attributes of all the matching records. Option 2 allows the county to receive the attributes of the school that's closest to it. In this example, the second option is nonsense. All the schools are in the county, so it avails little to assign the closest one. In this case, the summarized join is the appropriate choice. The slide shows the results of the spatial join between the schools and the counties, with counties as the destination table. The resulting layer is a map of counties with the original county attributes, plus a field called count, containing the number of schools in the county. From this field, the graduated color map was created, showing the number of schools in each county. When summarizing, you can choose from several statistics such as minimum, maximum, average, and so on. All numeric attributes in the source table are summarized using the statistics you chose and placed in the output table. String fields cannot be summed or averaged, of course, so they are not included in the output table. Spatial joins will fall into four main types according to the cardinality of the relationship between the join layers, simple or summarized, and the choice of spatial criteria, inside or distance. A simple join may be used whenever the cardinality is 1-to-1 or many-to-1, so that the rule of joining is maintained. Summarized joins are used when the one-to-many relationship exists. The available join types will depend in part on the geometry of the features being joined. Points to points, the inside join cannot apply, leaving two available options: simple distance and summarized distance. This slide shows an example in which the distance join is the most appropriate choice. Most counties in South Dakota do not have a hospital, and we wish to know the hospital closest to each county and how far it is. The hospital points have been joined to the county polygons, with the counties as the destination table. A distance join is chosen. The output shapefile always has the same feature type as the destination table, polygons in this case. After the join, each county has a field indicating the name of the closest hospital, as well as the distance from the county to the hospital, in decimal degrees in this case. A unique values map was created based on the hospital name. In the northeast part of the state, it's easy to see that the pink counties are closest to the hospital in the pink area, the yellow counties in the yellow hospital, and so on. The long hatchet-shaped county in western South Dakota, Pennington County, has several hospitals. Since all three lie inside Pennington, they technically have a distance of 0. And Pennington's closest hospital was arbitrarily assigned based on which hospital was found in the table first. The blue counties in the central part of the state were assigned to a different hospital in Pennington. When a join based on distance is performed, a distance field is automatically appended to the output dataset, indicating the distance between the joined features. The distance is reported in the map units of the destination feature class. The input layers in this example have a coordinate system of GCS North American NAD 1983, so the map units are decimal degrees. The small map shows each county displayed according to its distance to the closest hospital. Notice that the counties with hospitals inside them have the smallest distance 0, and the central counties of South Dakota are furthest from any hospital. Distance and summarized distance are possible. In this case, summarized distance is used, which sum the total septic systems that are closest to each stream. Join types are available for each combination of featured geometries in a spatial join. This is a partial list of join combinations. A full list is found in your text. Consider the simple distance. Find the hospital closest to each town. The summarized distance would find all the towns that are closer to one hospital than another hospital. The simple distance join in this case can find the county that's closest to each hospital and give the hospital those county attributes. The simple inside join can find the county that each hospital is inside and give the hospital that county's attributes. In this case, consider polygons to line using the simple distance join. The park polygon attributes are assigned to the road nearest each park. The summarized join will give the interstate the total population of all the counties that it crosses. Not all combinations make sense, so as always, think about what you need and think about what you're doing. Polygons joined to polygons with simple inside join can give the urban areas the attributes of the county that falls inside of it. Using the summarized join, we can give each county the summarized attributes of the urban areas that fall inside of it. When joining polygons to polygons, the simple inside join can find the park that each lake is inside and place the park's attributes into the lake's table. The summarized join can give the park the total area of all the lakes that fall inside of it. Notice, not all lakes fall completely within a park. Remember, not all joins are capable of giving valid results. You have to think. These joins might seem complicated, but the software helps narrow your selections down, and you read the options carefully. The correct choices should make sense after a little thought. Distance joins record the distance between features in a field. The distance unit of measure is based on the coordinate system. You should use projected coordinate systems that preserve distance when using distance joins. It's not easy to convert decimal degrees to miles because the conversion factor varies with the degrees of latitude. A geographic coordinate system or a projection that distorts distance will likely yield incorrect results. The source coordinate system is used as opposed to the data frame coordinate system. It might be necessary to project the source data into an appropriate projected coordinate system. Now we'll try to show how to join using ArcMap. In a spatial join, the attributes of the feature in the source layer are appended to the features in the destination table. The output layer always contains the same features as the destination table. When choosing the join, keep in mind the cardinality of the join to pick the most appropriate option. The types of joins available will depend on the feature classes being combined together. Point-to-point versus point-to-line, etc. The cardinality of the relationship between the two. The join menu automatically determines the type of options available based on the feature types being combined and asks you to choose between two options. Right-click the destination layer in the table of contents and choose Joins and Relates Join. Choose to join another layer based on spatial location. Choose the source table from the drop-down box or click the Browse button to choose one on a disk. Choose one of the two join options and specify any summary statistics you may want, if applicable. Specify the shapefile or feature class to contain the new output layer. For more information on joins, click the About Joining Data button. Click OK to execute the join. You will be limited to the choices based on the type of geometry selected. Read the options, think about what you want, and make the right selections. You can't do anything without reading these options. When collecting summary statistics, you should know that the statistic will be calculated for every numeric value field in the table. Don't let this worry you, because you can always turn off undesired fields using the layer properties. When creating spatial joins, always right-click on the destination layer in the table of contents to start the process. These tips will help you decide on the options to select. How should the features and tables look? What is the destination? Which is the source? What is the cardinality? Will a simple join work, or do you need to summarize? If you have any questions, give me a call or send me an email. Thanks.